Let me start today total internal reflection topic from chapter 9 ray optics of class 12th standard physics. Okay, what is total internal reflection? Ordinary mirror is required for causing reflection, plane mirror or convex mirror, concave mirror. But here without mirror we are going to study about total internal reflection. How total internal reflection can be caused without mirror with the help of two optical medium. So what is it? If we take some pond of water or you take some beaker with water, so there is interface separating air medium from water medium. Got it? Now we have some object at the bottom of the water. Got it? So here water is present in this real thickness. Okay. Now I am going to view this object O from different angle of inclination from air surface. First let me view through the point A normally. So ray from object goes normally, for which angle of incidence is 0. It will go straight, for which angle of refraction is also 0. Then another point if we take, it is incident at angle greater than 0, angle of incidence I greater than 0. It will go in such a way the angle of refraction is also more than 0. And you take any other point, third point, this is A point, A1 point, A2 point if you consider and draw the normal. The refracted ray will go along the water air interface, means here the angle of refraction becomes 90 degree, and that particular angle of incidence in denser medium is called as critical angle of that denser medium. Its value depends upon another medium you consider here for refraction. In this case it is critical angle of water with respect to air. If it is glass, critical angle of glass with respect to air. Okay, now let us consider the point A3. The ray goes with I greater than critical angle in denser medium. At that time you can't expect any more refraction. Instead it will be totally reflected inside and obeying law of reflection such that what is the value of angle of incidence here, the same is the angle of reflection also here. So here the full light energy coming from the object is reflected. So intensity of the reflected light is equal to the intensity of incident light. That's why we call it as total. Internally inside the same denser medium the light is reflected. So it is called total internal reflection. Now what is meant by total internal reflection? It's a phenomenon in which when light is traveling in denser medium to rarer medium and it is falling at an angle of incidence greater than the critical angle of that pair of medium, it is totally reflected inside the same denser medium. This phenomenon is called as total internal reflection. Okay, this point when I is called as critical angle in this denser medium, for which angle of refraction in rarer medium is 90 degree. If we take it, that special case, we can derive one expression for refractive index of denser medium with respect to rarer medium. Here it is water and air. So if we take light travels from water to air, means in water there is angle of incidence equal to critical angle when angle of refraction in air is 90 degree. I am writing this here for your understanding. So this answer is equal to sin I by sin R. If we take, it will be sin I by sin R, and here I value I consider C when R in air is 90 degree. So now after understanding this, it's erase it from your mind. You just write it in your mind. No need to write here. And I want now refractive index of water with respect to air, which is called as absolute refractive index of water. is equal to reciprocal of refractive index of air with respect to water, means this is 1 upon sin C. So one more excellent formula we got for refractive index along with all other formulae what we learnt earlier than this. So refractive index of water is equal to 1 upon sine of critical angle of water with respect to air here. Now if you take this, some more interesting relationship between refractive index and critical angle. As it is sine, we can write it as refractive index and critical angle are inversely related with each other. Example, if you take for let us start from water. For water medium, refractive index answer is 1.33, means critical angle answer is 48.7 degree. For glass, the refractive index is 1.5, means the critical angle value is 42 degree approximately we can consider. For diamond, which has highest refractive index, it is optically densest medium. So for diamond, the refractive index value is 2.42, means the critical angle value for diamond is 24 degree. So from this, what do you understand? When refractive index increases, critical angle decreases. The same way for different colors also you can take. VIBGYOR, if you take, when you go from violet to red, wavelength increases. So wavelength increases means the refractive index value is inversely proportional to wavelength. Wavelength more, refractive index is less. So refractive index decreases when you go from violet to red. So because of this, mu u is inversely proportional to lambda, and mu is also inversely proportional to critical angle. You can consider critical angle for different colors. Mu decreases means critical angle value increases. These points are very much useful for MCQ related questions and for simple 1 and 2 mark numerical. Okay, now what do you mean by total internal reflection? You understood? It's a wonderful phenomenon in which a ray of light traveling from optically denser to optically rarer medium and has angle of incidence in optical denser medium greater than the critical angle falls. The total light energy is reflected inside the denser medium. This phenomenon is called as total internal reflection. Okay, now if we come to the conditions of total internal reflection, there are two essential conditions. First, the ray of light should travel from denser to rarer medium, optical denser to optical rarer medium, the ray of light should travel. Then angle of incidence in denser medium should not be in rarer medium, should be greater than critical angle of that denser medium. If it is water, the angle of incidence in this place should be greater than 48.7 degree. Then only this total internal reflection will take place. Okay, now what are the applications of total internal reflection? If you come to that point, it's applications of total internal reflection. Applications. It is used in medical investigations, where it is in the form of endoscopy. Nowadays, if we have any internal organ problem, we go to hospital, they insert some tube inside and the tube is connected to computer. So they send the light through the tube inside the stomach, and that light is carrying the image of the organs present inside and coming back, and that is shown on the computer screen. So whatever organ is affected, any problem is with that internal organ, it can be investigated by using optical fiber is used, but that is using the phenomenon concept total internal reflection. Then mainly if you come to light related phenomenon, the path of light can be deviated by 90 degree by using right angled prism, which are called as total internal reflecting prism. It is right angled prism. So if light is going like this, the path can be deviated by 90 degree. So how is it possible? Just you take a prism which is called as isosceles right angled prism. So two sides are equal. If you take, this is the prism ABC, this angle is 90 degree, then it is called as right angled prism. And these two sides are also equal. These two angles 45 degree, 45 degree. So 45, 45, isosceles right angled prism. Suppose I am having source of light, bulb. It can emit light in this way, but I want to deviate by 90 degree towards that side, means I allow it to fall on this AB surface normally. So normal incidence means normal refraction in denser medium. This is glass medium, this is air medium. Again it travels in denser medium, and at this surface BC, if you make normal, this incident angle is 45 degree, and glass, critical angle of glass with respect to air is 42 degree, just now I told. So angle of incidence in denser medium is more than critical angle of this glass medium, means it won't undergo any refraction, it will be reflected, and it also obeys law of reflection. So angle of incidence is equal to angle of reflection. So when it goes like that, for this surface it becomes as normal incidence at this point, for which I is 0, means again normal refraction. So ray of light coming through one surface AB undergoes normal refraction, and on this BC surface it is totally internally reflected once. So the path of light coming like this is deviated like this, total 45 plus 45 degree means 90 degree deviation happens. So that is first application. This is for point object. The source is point object. If you want to construct it for extended object, say AB is an extended object. So from B also one ray of light coming, and from here again total internal reflection it takes place. So if it is A dash of A, this point will be B dash of B, means here the image becomes A dash to B dash, like this laterally inverted image. So A appears here bottom, there on the top. Here it is not inverted, actually it is laterally inverted. Left side will appear as right side in the image, right side of the object will appear as left side in the image. That is called lateral inversion, like normal mirror showing lateral inversion, like that. The same way here it is for deviation by 90 degree. We can even deviate ray like this. If it goes, it can be sent back. So deviation is 180 degree. For that you should keep the base and right angled like this. This is right angled A position. The base of the prism BC should be like this, means now I keep one point object, means it emits light like this, and the ray goes normal refraction. At this point again angle of incidence 45 degree is more than 42 degree, and it is totally reflected downward. Again at this point perpendicular to this surface normal. These two lines are called as normal lines. Again 45 degree, which is greater than critical angle, so undergoes total internal reflection. So first time total internal reflection at this point, second time total internal reflection at this point. Here again normal incidence, normal refraction. So this is the image. If it is A point, this image is A dash. So here 90 degree, here 90 degree. So totally 90 plus 90, 180 degree deviation of the ray of light. If you want to take it as extended object, AB, suppose I am taking like this B point, and from B it will go like this. First total internal reflection, second total internal reflection, and here normal refraction it happens. So B dash is like this. Here also if you keep the object AB like this, image B dash will be here, A dash will be here. It is AB, B dash, A dash image will be of same size. So here deviation of light by 180 degree. Here deviation of light by 90 degree. So this light can be deviated by 90 degree and by 180 degree by using a right angled isosceles prism. The same the same phenomenon is also useful in the case of sparkling of diamonds. If you take brilliant color of diamond, sparkling of diamond, how it is? Diamond, suppose we get some spherical stone. Diamond critical angle is 24 degree. Because of less value of critical angle, we can give large number of flat surfaces for the diamond stone. So this is made of diamond. One spherical diamond stone, if it is given, the diamond cutter can give large number of small flat surfaces very easily, because the critical angle for diamond is very less. Because of this reason, suppose light is going with small angle of incidence in rarer medium, so there is no total internal reflection, just it will refract and go like this, or it may go like this, and here the angle of incidence will be less than 24 degree. And second condition, it travels from diamond to air, means it won't undergo any more refraction. It will be totally reflected and collected at some surface. Again it collected up due to total internal reflection. So inside only multiple times total internal reflection taking place, and at last when through some surface, when angle of incidence becomes less than critical angle, in such case it will come out. Then at this point, if angle of incidence is less than critical angle, it will come out. When it comes out through the surface, that surface gives sparkling effect. So the brilliant colors of diamond, it is because of total internal reflection taking place, and the light emerges through many surface, and here the critical angle is very less, so very easily angle of incidence becomes greater than critical angle. So because of the total internal reflection taking place, and this total internal reflection is causing mirage. What is mirage? Mirage in detail it is not in syllabus, but mirage if you take during hot time, noon time, if you take the surface of the earth, when you go upward, the density of atmospheric air is more. So because of that, if you are standing here on coal tar road during hot time, noon time, or in desert also, this phenomenon using total internal reflection is observed. If there is any tree in the distant, as if there is pond of water and there is its reflected image is formed, like that some illusion. That illusion is due to total internal reflection. So mirage formation is an optical illusion. With the help of light, the total internal reflection phenomenon taking place, and it gives the impression as if there is a pond of water, and as if there is reflection of image is formed, image of distant object and all is formed in the nearby pond of water. That impression gives something like this, shaking also we can see during noon time, during summer time. It is how noon time, the atmospheric air is pushed up, means near the surface of the earth the density of atmospheric air is less. So when the light comes from denser to rarer, the first condition of total internal reflection takes place. It bends away from normal. Denser to rarer, it bends away from normal. At a particular layer of the atmosphere, I becomes greater than the critical angle of that pair of denser rarer combination. So it will be totally internally reflected, further no more refraction. So the reflected light appears to come from here. When the observer observes from here, for him the reflected light appears to come from here, means this part image A dash is formed here. Like that, different parts of the object, different parts of the image is formed. It is called mirage. It is an optical illusion due to total internal reflection phenomena. One more very important application of total internal reflection in optical fiber. What is optical fiber? You must know its construction. If you take its construction, there are three main parts, mainly two parts required, the third part just some coating. The main part is called core, and it is surrounded by second part called cladding, and both are given some safety, that is called buffer coating. That is buffer coating, that is safety layer. So if you take these three, what is core? Core means many strands. Optic fiber, no, it is lengthy tube. It can be installed thousands of kilometers on the surface of the earth or in the ocean also. For many applications, we will know using total internal reflection. So what is core? Many optical thin hair-like structure made of fine glass, fine sand also. Sometimes quality sand is used. Quality sand or fine quality glass material is used to make hair-like structure, and they all are combined together to form bundle-like structure. This is called core. This core, if you take after this core, there is cladding. What is cladding? This cladding is also a kind of glass material only. It is surrounding this. I give separate shade for this cladding. This is cladding, and cladding is also made of glass only, but its refractive index, cladding refractive index mu2, core refractive index mu1. mu1 value is 1.52 and mu2 value is 1.48. So mu1 must be greater than mu2. Then there is safety coating given for not breaking this fiber. So this is called as safety coating, that is buffer coating we say. So this is cladding, this is core. I am not writing inside, I am writing here. Now this tube is of very long length, maybe 1000 kilometers, 2000 kilometers, depending upon our requirement. We can install it under ocean also, or on the surface of the earth also, like this. Now what is the use? This is called optical fiber. This optical fiber, we know ray optics, light travels along a straight line, but this optical fiber makes it to travel along a curved path by using total internal reflection. How? Light from a bulb enters here. Suppose light is entering here. So now you know three parts construction of optical fiber. Suppose I am having a bulb here, and it is very energetic light, maybe laser light we can say, and it goes, and due to refraction it goes through the core, and after here it meets core cladding interface. This is core cladding interface. So core refractive index is more than cladding interface, means it undergoes total internal reflection, because at this point angle of incidence is greater than critical angle. So no other way other than total internal reflection. Again it undergoes total internal reflection, because at this point also I is greater than critical angle. In this way the light through optical fiber total internal reflection follows a curved path, otherwise it cannot go along the curved path. The total internal reflection, even if the optical fiber is bent, the total internal reflection makes it to follow the curved path. If you take one toy, you would have noted down, there is pot like structure toy, and it goes like this, and from this there are some fountains of tubes coming, fibers coming, you would have seen, and here this part is hidden, and here there is a bulb connected to electric point. This is bulb connected to electric point, and here when we switch on this bulb it emits light. That light is passing through this optic fiber. When it is passing through this optic fiber, we cannot see this light. So when it comes to the tip only, it gives like fountain of light. This we can see the light spot only on the tip. The toy is very interesting toy. If you get a chance, please buy this and keep it in your cupboard. It gives beautiful look. That is toy making use of the phenomenon called total internal reflection. Okay, now we studied about optic fiber and its construction. What is the use? Suppose this is optic fiber, and inside core is there, cladding is there, core is there. Many such optic fibers are forming many such, not only one optic fiber, they are making many optic fiber together. It is called as light pipe. It is called light pipe, means how water is sent through a pipe, like that light is sent through a pipe. So along with that light, you want some we want to send some information, we can send it along with that light. So light is carrying the information and passing through the pipe. That pipe is called light pipe. So many optical fiber, this is one optical fiber, this is one optical fiber, this is one optical fiber, and all are bundled together. That is called light pipe. So here it may be thousands of kilometers going from one part of the country to another part of the country, long distance. So nowadays different parts of the country, internationally also and nationally also, it is various parts of the country, they are connected by optical fiber to share information with each other. Okay, how information is sent? So it is not only one optical fiber, it is many optical fibers joined together is called light pipe. So each and every pipe is, suppose I am having some image, I am having some documents, it is some document. This document, it is written and it has some picture also like this. So here there is a energetic light emitted by a source, intensive light emitted by a source. That light passing through this will scan this image, and this part of the image carried by 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 this optical fiber, and by total internal reflection without being lost somewhere, anywhere in between, each and every part of the image is brought on the other side. So here the light is reaching, it is transmission of light, reception of light. So when the light is transmitted and it is scanning the documents, so it carries the image of the document and comes to other end, and it is received here. When it is received here, the document is separated from the light coming through this pipe. So after separation, the document can be printed with whatever image and whatever written part. So in this way, the document can be scanned and transmitted. So in this way, optical fiber is used for effective communication. In telecommunication also, our information, audio signal, video signal can be carried by means of light. So those electrical signals should be converted into light signal, and that light signal carrying the information and transmitted here, received here. So in this way, for telecommunication also, optical fibers are used. In endoscopy also, to see the internal organs of the body, the optical fiber is sent inside the stomach through the mouth, and light is passed through the optical fiber. It is falling and carrying the image of the internal organs and coming back, and it is sent to computer. On computer, any internal organs having any problem, it can be analyzed, investigated, treatment can be given accordingly. So in endoscopy also, optical fiber used. So many applications of total internal reflection. Even if we are not appearing for exam, if we know about total internal reflection, we will feel immensely happy. So please learn total internal reflection. Thank you, children.